Welcome to the class. Let me start the lecture. As you know, in the previous lecture, I talked about how to test, how to writing test script via JUnit for several situations, such as controlling the null exception handling in our test codes. So for this aim, we explain one of the examples of our textbook, which is a simple class in which we write a method for finding the minimum number, the minimum element of a list in any comparable type, such as a list of integer, list of float numbers, list of characters, and so on. And we had explained the specification of the min class, and we talked about how to implement the min method of our min class, and in this method we talked about what considerations are necessary in implementation, such as checking the null lists, checking the empty lists, and return appropriate exceptions, such as checking the class cast, in which we expect that all elements of a list should be in the same type, but when we define arbitrary lists such as these, it is possible in Java programming language that elements of this list be of different data types, such as a number of its elements be an integer, and but the other elements be in another type, such as character. So as you know, the character is not comparable with an integer value. So this in this situation we should throw a class cast exception. In this example, we learned how to control, how to test the appropriateness of the thrown exceptions, and we have written several test methods for several purposes. If you remember the list of all test cases or test methods that we are written for this example are summarized in these slides. We check the null element with multiple in a list with multiple elements, a null element in a list with just single element, incomparable types, empty elements, or a list with size 0. All of these types, all of these forms of lists are tested through our test class. And in addition to these tests, we add two test methods to test normal lists, a list with just a single element and a list with more than one element, for example 2 elements. And you saw that how these tests could be run over the business class, the main class, and how to generate the appropriate reports about how many tests are failed and how many are passed. In this session, we want to talk about 2 other possibilities in JUnit, which help us to writing our test scripts better. In the first one, suppose in our simple elementary example, suppose this elementary example we have in which our business class is a calculation or calc class in which consists just one method, the addition method, which we want to add or calculate the summation of its 2 parameters and return the summation of its parameters. For this method, in previous lectures, we talked how to write a simple test method, such as this test method, the test method, in which we just use a simple assertion to check the actual value returned by the addition method of our business class to be equal with our expected result. For example, when we feed this method with by 2 and 3 for its parameters, we expected that this method returned 5. So we learned how to compare this expected result with our actual result, which returned by the method called the addition method of our business class. This is a simple method, but suppose we want to do test more, to define more tests to test thoroughly this method. As you know, each method should be tested several times to give us more confidence. So for doing more tests, for example, in this simple case, we should define more test methods. For example, if we want to test the add method twice, we should define 2 test methods. The test add 1 and test add 2. Okay, and this with different input values such as minus 22 and for example a non-negative value such as 30. Okay, and we expected that this method called returned which value returned minus 9. Okay, the expected result would be minus 9. And we run this test class again, such as this. So in this report, you see that all two test methods are run and there is no any failure or error. But for example, if we simply change this expected result incorrectly, we will see a test failure. Yes, this is, in this report we see that two tests are run and one of them is failed. Okay, the test cases which fails is this. Okay, but if we want to do more tests, we should write more test methods. Each test method compare the expected result with actual result by just one assertion. In this case, we use assert true. And if we want test more, we should define more test methods, and so we would have a heavy chunk of code. Okay, our test codes bloat with no logical reason. We should have a possibility to do this work simpler. JUnit provided us with a simple possibility, a possibility which we can do this work more easy. Let me see your messages. Excuse me. We can zoom in. You could exchange your screen to full screen, your video to full screen, and you can see it perfect. The text is small. Okay, I do that. Do all programs have a test program? I talked about the importance of testing in the beginning of our semester, this semester, and this is a managerial decision. This is a management decision. In some projects, some project managers want to test just some classes, some parts of their project or his project. But in some cases, our project manager is very sensible, and he wants to test the project thoroughly, and all parts of our program need to be tested. But especially some classes or some methods are more important than others. In that cases, the important classes, the notable classes should be tested, but the others necessarily don't need to test at all. Let me zoom the screen to see better our screen. I don't see the view menu. How I can change the size of our text. I don't know how to change the size of our code. We should have a menu titled View. In View we have a submenu titled Zoom. Show view, perspective, navigation, appearance. From window, yes. Okay. Zoom in. Editor, zoom in. Okay. Let me go back to our slides and define again the problem formally and how we solve this problem by the possibilities of the JUnit framework. As I said just before, the problem in testing a function multiple times with similar value. The problem is the function, the testing a function several times with similar combinations of its input parameters. And the main problem is how to avoid the test code plot. How to do this work easily. As a simple example, as I showed in our Eclipse IDE, the adding two numbers, such as the addition method of our calculation class, adding a given pair of numbers is just like adding any other pair. But for test trees in our showing, we have to define two test methods. If we wanted to test, for example, 5 times, we should define 5 test methods, and our code grows more and more, and this is a big problem in code management. So you are really only want to write one test, but you want to run them several times. You want to run it several times. Okay, the main problem is that we want to write a test method just once, but we can run it several times with different input data. Okay, this could be done by an approach which named data-driven tests in JUnit infrastructure. The data-driven test design, unit tests call a constructor for each combination, for each collection of test values, for each test case, actually. Okay, and in data-driven test design, same tests are then run on each set of data values, such as I will illustrate a simple example for you in our JUnit. Instead of copying our test method for several times, we just define this by another approach which called data-driven test design. This is an example of data-driven test design. When we use this approach, we define our parameters, our test set, as an array of our combinations. For example, in this case, for testing the addition method of our calculation class, this method has two parameters, a and b. So we should feed this method by two values, and we have one expected result, which is its return value. So in each of our test cases, we should define three numbers, two of them for its parameters, its input data, and one for the expected result. So our test set is defined such as this in data-driven test design. As you see, this is a test set with 1, 2, 3, 4 test cases. We have 4 test cases in this test set. In the first test case, the two parameters of our method call is the first two numbers of this combination, of this collection. Okay, and the expected result should be 2. The summation of 1 and 1 should be 2, and the summation of 2 and 3 should be 5, and 20 with 33 should be 53, and the summation of 3 and 7 should be 10. Okay, so we have 4 test cases in this test set. We have defined 4 test cases. Excuse me. So we have 4 test cases. We have defined 4 test cases in an array. We define our parameters such as this. So this is our test cases which defined by a set, by an array, and we should use this set as our test set, and we should call the add function for times. Each time we should examine one of these test cases. Okay, this is just that we want, because we want to write a test method once and call it several times. This is our test method. This test method is the same as this one, as this test method. So we have written our test method once, and we want to call this test method several times as needed. For example, in this data set, this test set, we should call 4 times, but we want this would be done automatically, not manually. Okay, the JUnit runner should be detected the number of our test cases automatically and run the test method once for each test case. So we should define in data-driven test design, we should define parameters. In this case, actually, we use a parametric approach testing. We write a test method once and call it for several parameters, for different parameters. Okay, so we should define parameters. This could be done in JUnit by defining a method which its name should be parameters. It's a standard in the JUnit code. It's not arbitrary. So these parameters should be started with @sign parameters annotation. Excuse me, this could be in another names, could have other names such as param. Let me test. But our annotation should be @sign parameters to show that this method define our parameters, define our test cases by returning a collection of test cases. A collection of test cases which each item of this collection should be of type array of objects. As you know, in Java programming language, we have a class object which any other classes which we define in our programs implicitly extend this class, implicitly inherit from this class, from the class object. So as you know, for example, when we define an object of type calculation, and when we use that object, we could see some methods other than more than this, just one method. This is because we inherit from the object class, which is defined in Java programming language. So the return value of this method should be collection of objects, which each element of this collection should be an array, such as this, because in this array we want to define the value of each parameters of our method under test, of the method under test, and its expected result. Okay, so we should define a method with any valid name, but it should be preceded by parameter annotation, @sign parameter annotation, and in the body of this method we should return a collection of our test cases. Each element of this collection is a test case. This could be done in Java programming language by this method. Okay, so just now we have our parameters, we have defined our test method, and another thing that we should define when we want to use the possibility of data-driven approach, a data-driven possibility of JUnit, we should define a constructor for our test class. So please note that our test class named by data-driven calculation test, calc test. Okay. As you know, to define constructor, we should define the method with the same name as the name of our class, without any return type. We have not defined. We have to not define any return value for our constructors. And this constructor should be defined by three parameters, in which each parameter is considered with the same parameter, same type of parameter as defined in our method, the method under test. In the addition method, the first parameter is integer. So in our constructor, we should define the first parameter as integer value. The second one is integer. The second parameter of our constructor should be again an integer value. And the expected result of this method should be an integer value again. So the third parameter of our constructor should define the expected result. As you know, the expected result is an integer. So this expected result parameter is defined as an integer value again. And in the body of this constructor, we should assign each of these parameters to the coordinated, to the corresponding according parameter, concrete parameter. We have two parameters in our method called A and B. So we have to define two parameters in our class, int A and int B, and one expected result we named it with sum. Okay, so in our constructor we set these attributes by the parameters of our constructor. We set the A attribute by v1, the first parameter, the B value, the B attribute with variable 2, the second parameter, and the sum is set by the expected result. So we summarize this method, the data-driven method. In data-driven method, we try to write our test method once and run it several times as needed according to our test set. For example, in this our test set, in this case, we have in this test set, we have 4 test cases. So we want to run it 4 times. Each time we run by one of these collection, one of these combination. Okay, so for this aim, we should define a constructor which assign each combination, each test case to the attributes of the class, and these could be used in our test method. As you know, in the test method we compare the return value of the addition method of calculation class for the two parameters a and b, and the return value is compared by sum. As you know, we have defined sum as our expected result. The JRunner, when see the annotation parameters, it determines that probably in this method there are a collection of test cases, and extract each test case automatically from this set, and assigns these values to our parameters appropriately, and the JRunner then call the addition test for the first test case, and JRunner will try again for the next test case, and do this process again for the third test case, and do this for the last test case. So when we run this class, this test class, when we run this test class, the JUnit reports that there are 4 test cases. There are 4 test cases executed by just a test method. Okay. In this class we have just a test method. So let me run this test class. As you see in the reporting, there are 4 test cases. Please note, all of test case show the addition test. This means that this addition test method run 4 times. 4 times. Let me change one of the expected result, such as this. We change this to an incorrect value. 1 plus 1 should be 2, but in this test case we define the expected result incorrectly to 3. So one of our test cases, and it is the first one, the first test case should be failed. Okay, we run it again and we check the result. Yes, it's true. In this report we see that 4 of 4 our test cases are run and one of them failed. The failed one is this. The failed one is this. If you check this, we perceive that the first test case is failed. The first test case in this collection is this one. It's okay, because our expected result is wrong. So if we fix this and run it again, we see that all test cases are run successfully. Okay, let me check your messages. Please repeat which part. Okay, I'll repeat it quickly. What's mean object? I explain it again, no problem. And this is mean two-dimensional. Yes, this is two-dimensional array. It's two-dimensional array. If you have any other question, please ask your question. I want to answer them. Excuse me, I turned off my mic for a moment. Let me explain it again quickly. Use assert library. Why? Because we use assertion. We use this assert true method. This assert true method is defined in assert library. We import this library there. Okay. Also, when we want to use data-driven approach and we have parameters, we should import this library, the parameterized library of JUnit runner. Okay, and our test class should be preceded with annotation run with parameterized.class, because we want to test parametrically. Okay, our test have several parameters. Each of our test cases would be one parameter for our test method. Okay, this is an approach, and I will soon define another approach to do the same behavior, to the same possibility by another approach in which we use J theory. Okay, let me explain again for you. Please note that what is the problem? What's the problem? The problem is that when we try to test a function multiple times in traditional testing approach, we should define multiple test methods. All of them the same with similar values. The similarity is not the same value. The values are different, but with similar combinations of our inputs. For example, I've told about the testing this method in traditional manner. When we want to test this method for several times, as you saw, we have to define several test methods, and we should copy this test method several times. Okay, each times in our assertion we call the method under test with a different test case, with a different test data. For example, in this test case, in the test method addition 1, we call the addition method of our calculation class by 2 and 3, and in test addition 2 we call this for example -2 and minus for example -5, and we expect that the result be -7. Okay, and in the third one we define our test values as 6 and for example 3, and the expected result should be 9. So in this test class, this is a test class. In this test class we have 3 test methods, and we do 3 test cases. We test our addition method with 3 test methods, with 3 test cases. As you see in this report, we run 3 test cases of 3. There is no errors, no failure, but when we change this incorrectly and run again, we see that the second test case is failed. Okay, it's because our test case is incorrect. In our test case, the expected result should be -7. Okay, if we want to test this addition method for several times, for example more than 10 times, with more than 10 test cases, we should copy this test method more than 10 times. Okay, we should copy this test method again and again and again and again, and our test class, the size of our test class will grow more and more and more, and this is actually a problem. This is a serious problem. We could not manage this class test simply. How we can heal with this problem? How can we treat with this problem? The JUnit solution for this problem is using a data-driven approach, as you see. So we come back to our slide. The JUnit solution for this problem is a data-driven approach. In this approach, we should define our test cases as our parameters of test method. Okay, we should define our test cases as the parameters of our test class, of our test method. To do this, we should use a new annotation such as @sign, such as this @sign parameters. To use this approach in JUnit, we define a data-driven test class. Okay, we define a test class preceded with this structure. By this structure, by this annotation, we say to the JUnit runner to use the parameterized class to run this test class. Okay, and in this test class, we should define a constructor to be called for each test case. This constructor automatically, the JRunner uses this constructor automatically to extract our test cases one by one, and when it called for each test case, it should be assigned these values appropriately to our parameters. We define these values according to our parameters and expected result in our test cases. The first value of each test case is the first parameter of our method, and the second value is the second parameter, and the third one is our expected result, the expected result. So we should define 3 attributes in this class, and these attributes should be initialized, should be set by our constructor. This constructor is different from the ordinary constructors in our programming languages such as C++ and Java. This constructor is called several times automatically. It's called for each test case once. But the usual constructors is called when we define an object of the type of that class, type of its class. When we define an object, an instance of a class, a constructor will be executed. But in the test classes, in JUnit, this constructor executed for each test case once. And we should define our test cases in a method which should be started by @sign parameters. Okay. And the return value of this method should be a collection of our test cases. Should be a collection of objects in which each object is a test case. In this, each element of this collection is a test case. For generality, in this case, we could define this as okay. In this case, we could define this collection as array of integer, because each of our test case is an array of integer. But for generality, in this example in our book, our test book, it defined by object class. The object class is a class which is defined in Java programming initially. It's not a user class. It's a systemic class. So in this case, we can use the integer type because our test cases is an array of integer. But for when we have some parameters in other types, one of them integer and another would be, for example, double or character, and when we have expected results such as Boolean type, there are different types should be defined in each test case, and all members of each test case, all values of each test case are not the same in the same type. When the types of them are different, we should define each test case as an array of objects. Okay, and this should be changed to object. Excuse me, object. Okay, this is usable. This could be usable when we have test cases in which each value of test case be in a different of a different type. But when all of values in a test case is the same type, has the same type, we could use, for example, in this case, an integer type to define our test cases. So, in this collection return value, each element of this collection is one test case, and each element of each test case is an array of objects. Okay, this is an array of objects as the other test cases. Each of these test cases is an array of objects. Okay, so we define our parameters by this method, and finally we should define our test method. So we summarize our speaking. We defined our test method once, but the JUnit runner calls this test method 4 times, each time for a test case. And when each test case is wrong, or there are some faults in our method, the addition method, for example, when we change this method incorrectly to return a minus b and run again our test cases, all of our test cases should be failed, because we suppose that our method return the addition of its parameters, and our test cases designed to the expected result be the summation of the parameters. So when we run these, all of test cases fail. We have run 4 test cases and all of them are failed. Why all of these test cases fail? As we check again, we see that our test cases are true, and when we go to the method, we see that this is wrong, this is incorrect, and when we fix it, excuse me, we should run this. When we execute again, we see that all test cases run successfully. The object is not the name of no. Object is the type of this array, the elements of this array, not the name of this array. This means that each element of this collection is an array of type object. So please look, when we focus on object, we see the reference of this object type. This is a class of Java language. Okay, and you can see the definition of this class and not the name of the array, but it is the type of the array. Okay. If you have any question, please ask your questions. Another possibility, let me see a slide. So this is the same as we saw in Eclipse environment. In Eclipse IDE, this is the same code, and in this slides, the test cases are informed. There are 2 test cases in this example, and in this example, the parameter method is defined as the same as that we saw just before, and this is the constructor of our test class. Our test class is defined with this structure and with this annotation. The test method is this, and so on. Another possibility to define test methods with parameters is the using of JUnit theories. The JUnit theories is a common possibility to define our test methods parametrically. All of test cases we have written until now are parameterless. Please look at this test method. This test method has not any parameter, and other test cases we have defined until now, if we check all of them, none of them has parameter. This is the previous the example, the problem of the previous lecture. All test cases defined in previous lectures have no parameter. So until now, we have not explained test methods with parameters. The JUnit theory is a possibility of JUnit framework to define test methods parametrically. Unit tests can have actual parameters. So far we have only seen parameterless test methods. In parametric testing, we use some new concepts such as assumptions, action, and assertions. Just like defining a theorem in Mathematica, when we define a theorem, we define some assumptions and define some actions, and finally we have some assertions to check. The assumptions normally are preconditions of our theorem. And the action performs activity under sacritime. Okay. And the assertions is post conditions. These concepts are defined in design methodology, which named design by contracts. In each contract, we have some assumptions, and by an action, we change the state of our problem, and we should check the post conditions of the action and check results. When the result is true as we have defined before, we say that the action run correctly. So when we want to define parameterized test methods by JUnit theories, we should use this annotation, @ theory, in the beginning of our test methods. And when we use this annotation, we could define some parameters for our test method. Let me show this by Eclipse IDE. I will finish the lecture soon. If you can continue, we show this example as our last example. Let me to continue the lecture, and you can see the recording again. Okay, no problem. The other example, the last example actually, we use the set theory test. We define another test class. We name this set theory test. In this class, test class, we use the theory class of JUnit runner. And this class annotated by this annotation run with theories.class. In this type of test script, we define our test method. We can define our test method with some parameters. This is different by all of the test methods we have written until now. This test method should be preceded by this annotation, @sign theory. We inform this method to a JUnit runner to use the theory class, and we say that this test method uses some parameters. In this test method, we want to check a simple action. The action that is tested by this method is that we have a set of string. And one another string, and we search in this set to find strings like this parameter, and if there is an occurrence of this string in this set, we remove this string and then added it again to the set and compare the result with the original set. If the original set changes by this action or not. It should not be changed by this action, because we simply search a specific string, and if we find any occurrences of this string, this specific string, we just remove it from the set, and then after removing, we added it again to the string, to this set, and check the result set with the original one. This activity should not change the set. For doing this activity, we have some assumption. One of these assumptions is that this set, this parameter, which named by SumSet string, the SumSet should not be null set, be a null set. So we assume one of the other assumptions is that our set is not null, and the other assumption is that this set contains this string. If this set not included in this string, the activity could not be done, because we want to locate this string in this set and remove it and then return back it to the set. When the set does not contain this string, This action could not be done. So our assumptions are these two assumptions. In J-unit theory, we define our assumption by this keyword, assume true. Okay, this condition should be true. This is a precondition, and this is another precondition of this test method. So we define our test method parametrically, which has two parameters, but in the beginning of our test method we have some preconditions about our parameters. Our parameters, the first parameter should not be true, and it should contain the second parameter. So if these assumptions are true, we can go ahead, we can continue to doing our action. What's our action in this case? In this case, we make a new copy of our first parameter of our set, and we remove the second parameter from this copy, from this set, and then added the second parameter, this string, again to this copy, and then finally compare these two sets, sum set with its copy. If the sum set and its copy are equal, we check this by this statement: sum set equals copy. If this is true, our test case passed, but else the test case will be failed, because we use a assert true. Our assertion is assert true. Okay, but how we feed these parameterized test methods? How we provide the parameters for running this test method? For defining the parameters of test method, we use another new annotation, the data point. As you know, we have two parameters in this test method. So we should define two data points. The first data point, for example, in this case, is a animals set, in which it's a set of strings. So actually, when we want to run this test method, any of these values, any of these strings could be sent to this method as this parameter, the second parameter, for the second parameter. But as you see, the first parameter is a set of strings. We should define another data points such as these. This is a set of strings. And this set of strings. In this case, we have defined 3 sets. The first set includes 2 strings. The second one has 4 strings, and the last one, the third one, has 3 strings. So we defined this set of values for the first parameter. The first one, the second, and the third set. The first set is these 2 strings. The second one is these 4 strings, and the last one, or the third one, is this, excuse me, is this set. So we have three collection for the first parameter, 3 combinations, 3 value for the first parameter, and 3 for the second parameter. Altogether, we have 3 times 3 test cases, because we can call this test method for this first set with any of these strings, and this set with any of these 3 strings, and so for the last set. So we have 9 test cases, but all of them are not applicable in this test method, because some of them has not these assumptions, could not provide these assumptions. For example, some of this set of string does not include any of these, does not contain any of these strings. So the combination of this set with none of these strings are applicable in this method. We could not use this string with any of the, because this set does not contain the second parameter. The second parameter are gained from, or extracted from this first data point. First. Okay. Excuse me, let me see your messages. Yes, I send this program for you. Please, we want all the codes for programs. Okay, I'll send it soon. No, son. Do you hear me? Please reply me. You don't have son? Please reply me. My connection is okay. There's no problem. Probably your nets are weak. Okay. That's okay. Okay, excuse me if your sound is weak. You receive sound weakly. I will send these programs to you, and there is no another concepts to talk about. The last one is this data points. I explained it for you. So because we use the IDE, the Eclipse IDE, and we have not to use the command line. I don't explain any more about these slides. And about JUnit 5, you can see our videos which I have sent you before via WhatsApp group, especially the complete video I have sent. You can see that for the new possibilities of JUnit. There are several new possibilities in JUnit 5. You could exercise them yourself. So we finished the chapter 3. The next chapter is chapter 5. I don't talk about the chapter 4. If you want, you can see the videos, the video materials of the Professor Jeff Food in his website, in the web page of the second edition of the textbook. So we don't speak about the chapter 4. It is not necessary, and there are several important concepts, important problems in testing in later chapters. So we continue our lectures with chapter 5. I finished. Let me finish the session, and there is no need to any time more. If you have any question, please ask your questions. Okay, I appreciate you for your attention, and see you next session. You're welcome. Thank you again.